Okay, in this lecture, I will talk about the Euler Cauchy equation at higher order and also the non-homogeneous. So up to now, we have considered the Euler Cauchy equation, which was the second order. Okay, so let me put the standard form of the Euler Cauchy equation of second order: x square y double prime plus ax y prime plus b is equal to 0. So this is the homogeneous second order equation. So up to now we have dealt with homogeneous second order Euler Cauchy equation. It is Euler Cauchy equation because the y double prime matches with the x square 2 and 2, and y prime matches with the x power 1 and 1. So it is the homogeneous Euler Cauchy equation. So for this homogeneous Euler Cauchy equation, we use a substitution which is y is equal to x power m. Okay, and after doing some manipulations, we get this characteristic equation. So this is the characteristic equation for homogeneous Euler Cauchy equation of second order. And depending on the roots of this characteristic equation, we can write the solution of the general solution of this equation. So if the roots are real and distinct, okay, so for example, roots are m1 and m2, okay, so then the solution of the homogeneous equation will be c1 x power m1 plus c2 x power m2, okay. And if the roots are of this characteristic equations are double roots, real and double roots and real double roots, so the solution will be y is equal to c1 x. In this case, there will be only one root m, okay, there will be only one root m. So in this case, the roots solution will be c1 x power m plus c2 x power m times log of x, okay, plus times log of x. So this will be the solution. And if in the second case, if the roots will be complex conjugate roots, so in this case the roots will be respectively m1 comma m2 will be alpha plus minus beta I in this form, okay, or for this equation. So in this case, this solution will be of the general equation will be it will be x power alpha will come with the x power times bracket a cosine, a will be the constant arbitrary constant, a cosine beta log of x. So this will be the argument for cosine, and then plus b cosine b sine beta log of x. So this will be the argument of sine, and then bracket closed. So maybe I can put the same kind of bracket on both sides. Okay, so this will be the solution. So these three cases we have already discussed, and we have already seen their examples. So if you have not, then you can go back to that section of the video and then you can have a look. So this is the brief review of the work which we have already which we have done up to now. So this was about the second order, okay, equation. We can also expand this work to the third order equation, okay. So for the third order equation, we will not apply this equation as the characteristic equation. We have to derive it, okay. So let's see it with the help of an example. So suppose we have equation x cube y triple prime. This is the third order differential equation, plus 5x square y double prime and plus 7x y prime plus 7x y prime plus 8y is equal to 0. So homogeneous equation, but third order. So for in order to get its characteristic equation, so what we have to do is we have to apply this substitution, okay. So in this case, then y prime will be mx power m minus 1, y double prime will be m into m minus 1 into x power m minus 2, and then y triple prime will be equal to m into m minus 1 into m minus 2 into x power m minus 3. So now we can input these things into here. So you can notice that I can even try to simplify the things. You can notice that if for y triple prime we have x power m minus 3 term, but this is going to be multiplied by x power 3. So the remaining will be x power m, okay. Similarly, if here we have x power m minus 2, this is going to be multiplied by x square, so the remaining will be x power m. So in this case, and similarly for here, all these values, we will in all these terms we will have x power m as common, okay. So, and the coefficient for the first term will be m into m minus 1 into m minus 2, so it will be x power m will be common, okay. So in the first term will be m into m into m minus 1 into m minus 2. The second term will be m into m minus 1. The third term will be m only, and the last term will be just 1, okay, that is equal to 0. And now we can just manipulate it. So we can cancel out x power m, so therefore only this m terms will remain. You can do this algebra, okay, and then you will get, what you will get is m cube plus 2m square plus 4m plus 8 as the characteristic equation in this case, okay. So this is a cubic root, so you can find by any method the root. In this case specifically we have chosen the values then you can easily solve it. So for example, if I try m is equal to 2, or you can even use Mathematica to solve it. So let me show how it is done on Mathematica. So this is the Mathematica interface. So okay, this is the Mathematica interface. So maybe I can write this equation, and using the solve command, solve m cube plus m, the equation was 2m square, 2m square plus 4m plus 8 equal to 0, and then I will solve it with respect to m, bracket closed. So this is the equation, and then I can immediately get the roots as m minus 2 and m minus 2i and m plus 2i. So we have three roots over here. So coming back to the here, so the roots are, we don't need to try over here, so we can say that the roots are m1, m1 is equal to 2, minus 2, m1 is equal to minus 2. This is what we got. m1 is equal to minus 2, yes. M is equal to, m2 is equal to, and m3 is equal to plus minus 2i. So now we have three roots. So one of them is the real distinct root. Okay, so we can write it based on our previous understanding. So we can write its distinct root. So this is the distinct part, and these are the complex conjugate. So complex conjugate roots will be always be in the complex roots will always be in the pair. So that's why we call them complex conjugate roots. So solution will be c1 x power minus 2, okay, and plus here, because complex part is in the form of alpha plus beta, okay, alpha plus beta. So alpha is 0 in this case, so there will be no alpha term over here. So that means x power alpha will be 1. So only a and b, these terms will be there, and beta is 2. Beta is equal to 2 in this case. So therefore a sine of 2 log of x, and then plus b sine of 2 log of x. That will be the solution of this third order homogeneous Euler Cauchy equation. Okay, so next we will consider the non-homogeneous Euler Cauchy equations of second order. I will continue it in the next video clip.